General relativity definitely is a big mathematical achievement, but also here, as in special relativity, Einstein developed some mathematical model to describe gravity. But actually, this is a trick, because what is really missing in general relativity is we know that the gravity is force, and we measure force with newtons, with unit. I mean, Newton, it's a unit to measure force, also gravitational force. And in general relativity, we don't have units. So the curvature of space and stress energy tensor, and these are only mathematical tricks to describe gravity as a result of the curvature of space. So Einstein said material object is diminishing, is actually material object is increasing curvature of space, and curvature is carrying gravity. This is a very potent idea, because this idea means that gravity is not a force between two physical objects. Okay. Gravity is not a force between two physical objects, but two physical objects are deforming space. They create a curvature, and curvature is carrying gravity. But finally, we have to admit that general relativity is not a physical theory. This is mathematical theory. And today, we have hundreds of articles on the subject of general relativity, and nobody is pointing out that the general relativity is not a physical theory, it's mathematical theory. And the consequence of general relativity is that somehow in physics, now there is opinion that gravity is not a force. If gravity is not a force, so what is gravity? All the physicists which are teaching at universities that gravity is not a force, I suggest take 5 kilogram iron, take it and push your leg in the front, and take this weight and just make it flying, make it fall, free fall on your leg, and you will see that the gravity is a force. So what happened? After that happened that Professor Roger Penrose developed this idea that in the black holes curvature is infinite, and that we have a gravitational singularities there. But nothing like this in universe exists. Gravitational force in the center of the black hole is zero. According to the Newton shell theorem, that actually we know that actually is a part of fundamental physics. Nobody say that Newton's shell theorem is not valid. Everybody knows this. When we go in the Earth, the gravity is diminishing. The same is when we go in the black hole, inside the black hole, which would be better to say inside the black star, because there is no hole there. There is a star there that is extremely dense. So, what is from my point of view, the main intellectual achievement of Albert Einstein is that inertial mass and gravitational mass are equal. This is all of extreme importance. And what actually does it mean that they are equal? They are equal because they have the same origin. Inertial mass and gravitational mass have origin in the variable energy density of space. So a given physical object is diminishing variable energy density of space exactly for the amount of its mass and correspondent energy. And that's why in the center of the object, energy density of space is lower, and there is a pressing force towards the center. And as space is four-dimensional and objects are three-dimensional, they are following, they are obeying this force. Yeah, and that's why this, if I put it here on the table, it will remain here because the pressure of the space from all sides is keeping this object here. But when the object is moving, it will move forever. Why? Because the diminished energy density of space is moving with the object. In a very simple way, we can say that in the ether, there is no friction. Yeah. And the local diminished space is moving with the object and also is rotating with the object. That's why we have precession of Mercury perihelion. That's why, because the sun is rotating also space. And that's why Mercury and all other planets have precession. This is it. Physics can only progress if we acknowledge that universal space is a type of energy. Universal space actually is ether. This is superfluid quantum space. And without this, we will never progress physics, really. So general relativity is a huge mathematical achievement, but it has no correspondence in physical world. Yeah.